Hello friends, good morning. This lecture generally consists of the following lecture of our precedence graph or transaction part 1. This lecture consists of view serializability. One of the serializability I left this topic. In my last lectures I covered about on the topic of conflict serializability and precedence graph and all the other techniques by which you can find as whether a serial schedule is a conflict serializable or not. But in this lecture I am going to talk about another type of serializability. It is called view serializability. It's also very important, and several questions are coming in the examination. So what is view serializability and what are the conditions ensure that a schedule is view serializable or not, and what are the problems are there, and how view serializable is related with the conflict serializability. So let's start with a discussion of view serializability. Okay, so let me share the screen. So this is a definition of view serializability. So we can say that view serializability is less stringent than conflict serializability. So conflict equivalence of conflict serializability is more stringent than view serializability. Okay? But just like conflict serializability, for sake of simplicity, we will the view serializability and its view equivalency depends on two operations, read and write operations. Okay. So let's first check what are the conditions that should be ensured to becoming a schedule is a view equivalent schedule. Okay, so a schedule is view serializable. A schedule S is view serializable if it is equivalent to any serial schedule, right? View equivalent to any serial schedule, and two schedule S and S dash are view equivalent schedules if these three conditions are met. Okay, two schedule S and S dash are view equivalent schedule if these three conditions are met. Try to understand what I'm trying to say. Okay, so what are these conditions? These three conditions, just like the conditions of conflict serializability, these three conditions are specific to a view serializability or view equivalency of two schedules. Okay, the first conditions say that the one thing should be common for all the conditions, just similar to conflict serializability, is that all the transactions, all the operations should be performed on the same data item for each data item q. So here we will consider q as the same data item. Okay, if the data items are dissimilar, then there is a no conception, no conditions are met. Okay, this is similar to conflict serializability. So what is the first condition of view serializability? If transaction Ti reads the initial value of Q in schedule S, okay, these two schedules I am trying to make view equivalent. So if transaction Ti reads the initial value of Q in schedule S, then that same transaction Ti reads the same initial value Q in the next in another schedule S dash. Okay. So if transaction Ti, okay, suppose the first instruction is the read instruction. Okay, what is the read instruction? Read instruction on the data item Q in transaction S. Okay, then in S dash, another schedule S dash, if it is view equivalent to S, then read Q operation should be performed as the initial operation in the S prime schedule. Okay, so the first condition tells this. Okay, we will check some example how view equivalency maintained in schedules. Okay, next condition tells that for each data item Q, if transaction Ti executes read Q in schedule S, and if the value was produced by write Q operation executed by T transaction Tj. Okay, so in a schedule S, for each data item Q, suppose read Q operation is produced by transaction Ti, and transaction Tj perform the write Q operation just after read Q operation in schedule S. So the same order, same sequence of computation should be maintained in S prime as well. That means in S prime, if there are two transactions Ti and Tj, the Ti first produce the read Q operation and then followed by Tj produce the write Q operation. So for first condition and second conditions, it will be sure that all the conditions should be met on the same data item Q. The first thing that must be ensured, and second thing must be ensured about the perform of the same computation. Okay, that means whatever computation has been performed in schedule S for one transaction Ti or multiple transaction Ti and Tj, the same sort of computation, same sequence of computation should be performed in S dash. Okay, for different transaction Ti and Tj. Okay, now the third conditions. What is the third condition? Third condition ensures that the same the state of both the schedule S and S dash should be the final state should be similar. Okay, the final state of both the schedule S and S dash should be similar. The third condition tells that thing. So let's take the third conditions for each data item Q. The transaction that perform the final write Q operation in schedule S must perform the final write Q operation in schedule S prime. Okay, so in both cases, in both schedule S and S dash, if the final operation is a write Q operation, okay, in schedule S, then the final operation in schedule S dash must be the write Q operation. Okay, so the third conditions ensures the system should be in the same final state. Okay, and the first two conditions ensure that the computation should be performed on the same data item q, and the computation should maintain the same order of same sequence of computation or same order of computation. Clear? So these three conditions we'll have to remember in our mind whenever we have decided that whether a schedule is view equivalent schedule or not. So let's take one example. The example which I already discussed in my previous lectures. Suppose this schedule 1 and schedule 2. Look at the schedule very carefully. This is schedule 1 and this is schedule 2, which I already discussed in my previous lecture, and schedule 3. Okay. Now I'm going to show you in schedule 1, 2, 3, which one is view equivalent, which schedules are view equivalent schedules. Okay. The two schedules we will consider whether they are view equivalent or not. We will check. So let's first check, consider two schedules, schedule 1 and schedule 2. Okay, these two are serial schedule, and our main aim is to tell or is to identify whether these two schedules are view equivalent or not based on those three conditions. Okay, if you forget, please read out those three conditions once more or listen to the lecture of three conditions once more, and then come back to identify schedule 1 and schedule 2, are they view equivalent or not. So let's check it out. In schedule 1, the what I said, according to the conditions, the reading writing operation should be performed on the same data item. So we will consider these operations. Suppose in transaction T2, it performs the read operation on the data item A, which has been already read by transaction T1. Okay, so T2 perform the read operations after T1 executing the read operation on the same data item, similar data item A. Now we will check the T2 and schedule 2 whether it will do the same similar sorts sequence of computations. So we will check on data item A. Obviously, T1 perform the reading operation on data item A after T2 perform the reading operation on data item A. So obviously, it will not follow the same sequence. Schedule 1, T1 first perform the read operation after before T2 perform the read operation, and in schedule 2, T2 perform the read operation before T1 perform the read operation. So obviously, the sequence of computations or order of computations are different. So in so second condition does not fulfill or does not meet. Okay, because second conditions I told that the sequence of information should be similar, same set of computation should be there in both the schedules. So this schedule 1 and schedule 2, we cannot say these two are view equivalent. Now we will consider schedule 1 and schedule 3. Let's consider it. The schedule 1, we know that the T1 perform the read operation first and then followed by T2 perform the read operation. Now check the schedule 3 whether it will follow or not. Yes, schedule 3 follow the similar sort of operation of schedule 1 because it first performs the T1 performs the read operation and then followed by T2 perform the read operation. So T1 first perform operations and then followed by T2. So T2 waits for the T1 operations complete. In the same way, in case of B account or B data item, the same thing is happened. T2 is waiting to perform the read operation on B after T1 perform the read operation. So for both account A and B, it maintained the same order of schedule. The first T1 perform, then T2 perform. First T1 perform, then T2 perform. So in case of schedule 1, it will also say first T1 perform, then T2 perform. Right? So it maintains the sequence of computation as well as on the same data item A. So it ensures the first operations. Okay, it ensures the first two conditions met. So we can say schedule 1 and schedule 3 are view equivalent. Clear? The schedule 1 and schedule 2 are not view equivalent, whereas schedule 1 and schedule 3 are view equivalent. So let's go back to our lecture. So these are the things which I discussed. I already give the example of schedule 1, 2, 3, which are view equivalent and which are not. Now the concept of view equivalency leads to the concept of view serializability, which I already discussed, that a schedule S is view serializable if it is view equivalent to a serial schedule. Okay. Now view equivalency conditions, these three are met. Now we will check some more schedules and its characteristics. So one very interesting statement has to be we have to remember, because sometimes the questions will coming to justify that particular statement in terms of by giving examples by giving logic. So the statement tells that every conflict serializable schedule is view serializable, but vice versa is not true. That means there are view serializable schedules that are not conflict serializable. Please remember this statement is very, very important. Every conflict serializable schedule is a view serializable, but every view serializable schedules are not conflict serializable. As for example, this schedule 9. Check this schedule 9. This schedule 9 is a conflict serializable schedule. It's a perfect is not conflict serializable schedule. It is not conflict. Not conflict means we can make a cycle of it. Okay, if you draw the precedence graph of this three schedule, draw it by your own, and you will get a cycle in between the transaction T3, T4, and T6. So we can ensure that it is not conflict serializable schedule. But this not conflict serializable, every pair of consecutive instruction conflict. So we can say that is there any conflict instructions or not? So yes, it is there is not conflicting instructions. So every instructions are conflicts. That all the instructions are conflicting instructions. So we cannot do the swapping, because swapping can be performed only on conflicting instructions, or we can make a precedence graph from it, okay, to check whether it's a conflict serializable or not. But this schedule 9 is view serializable. Okay, they will check the final operations, all the operations, final operations are right queue operations. Okay, so as per the last conditions met, all the final state of all the schedules, all the transactions should be in the same state. So right queue operations, we can say it is a view serializable schedule. Okay, and since one read queue of instruction is initiated by queue in both schedules, and T6 performs the T4 and T6 perform the right queue operation on based on the read queue operation of T3. Okay. Now, one interesting thing that I need to tell regarding this schedule, that this schedule is a special type of schedule that performs that T4 and T6 transactions perform the write queue operations without having performing the read queue operation. Okay, so we will see from the table that this T4 and T6 perform the write queue operation, but the read queue operation they are not performing. They are depends on the transaction T3 for the read queue operation. These sort of writes are called blind writes. That means they are blindly write on the random queue based on the reading operation of the other transaction T3. Okay, so blind write appears in view serializability schedule that is not conflict serializable. So blind write appears for view serializable schedule. Please remember, blind write is appear only for view serializable schedule that is not conflict serializable here. Okay, so this conception is very important. What is blind writes? Give some example of blind writes, and the blind writes always appear for any view serializable schedule, but it is not conflict serializable. Okay. So this is all about the view serializability. I hope you understand what are the conditions and how we can check the view serializable schedule, whether a schedule is view serializable or not. So prepare it, and thanks for watching this lecture. Thank you.